Here's an image we all know well. It's an image which is in many ways a symbol of our times. It represents what is perhaps our greatest technological achievement so far, the step out into space. But the picture of our planet also has a far deeper significance. For the first time, we have seen ourselves and the planet from the outside, and the view has changed our feelings about ourselves in an unexpected way. For the early astronauts, the sight of the planet shining in the blackness of space was a profound experience. One of the astronauts who walked on the moon described his view of the Earth as an experience of instant global consciousness. He said, "When you're up there, you're no longer an American citizen or a Russian citizen. Suddenly all those boundaries disappear. You are a planetary citizen." And similar experiences happened to the other astronauts. They saw Earth to be a beautiful, magical-looking planet and came back deeply changed from that experience. Moreover, they became increasingly aware that all was not well back on Earth, and they came back wanting to help in one way or another. The pictures they returned with also had a deep effect on many of us back on Earth. For many people, it's an image which brings forth feelings of wonder and of awe, feelings of connection and of being part of something greater. In some respects, the picture of our planet is a spiritual symbol of our times. Now, that may initially sound strange. What is spiritual about it? But if you think for a moment, most spiritual symbols are, in one way or another, symbols of wholeness, of oneness, of some underlying unity. And a sense of oneness and unity is exactly what is reflected in this picture of the planet. It symbolizes the growing awareness that we are one humanity living on one planet and with one common destiny. This is why the picture of the planet is so powerful, and why it has become such an important symbol for all of those who are concerned about the fate of humanity and creating a better world. And there was another awesome realization which struck some of the early astronauts. Looking back at the Earth, it seemed that maybe the whole planet is a single living organism. Until we took the step out into space, we had only seen the planet from close up. Even when you're 10 miles up in a plane, you're still only seeing a very tiny part of it. In some respects, we could compare ourselves to fleas living on an elephant. Now, being scientific fleas, they've studied the skin, measured how deep it is, looked for the sweaty bits, found the hairy bits, and generally mapped out the elephant. Then, one day, one of these fleas takes a huge leap off, 50 feet away, and looking back at the elephant wonders, could this elephant actually be a living organism in its own right? We have been taking a similar huge leap back. From 100 miles to 1,000 miles, till eventually we see the planet as a single entity. And the question comes, could planet Earth be a single living organism? Now, this is not such a wild dream as you might suppose. A number of scientists are now beginning to take the idea quite seriously. Researchers in both England and America have been looking at some of the long-term changes which have happened to the planet. When, for example, you look at how the temperature of the planet has varied over the whole of its history, you find that it started off very hot, but then cooled rapidly until it reached the crucial range in which life could evolve. From then on, it seems to have remained steady. Now that's strange, because theoretically, it should sooner or later have started rising again, becoming far too hot for life to continue. But it didn't. It stayed constant. What seems to have happened is that the living organisms of the time released the right amounts of the right gases to keep the temperature of the atmosphere constant, at just the right level for life to continue evolving. Now that may sound an amazing coincidence, but it's no more amazing than the fact that our own bodies sweat when we are hot and shiver when we're cold, maintaining ourselves at a constant temperature. The salt content of the sea also shows an interesting degree of self-regulation. Salt is continually washed off the land into the sea, and at such a rate that it would take only 80 million years for the oceans to reach their present concentration. So theoretically, the oceans should by now become one huge Dead Sea. But they haven't. In fact, the salt content has remained remarkably steady. Somehow, small organisms in the sea have absorbed just the right amount of salt to keep it constant. These are just two of many examples which have led scientists to propose that all the living organisms on the planet together function as one huge self-regulating system, a theory known as the Gaia hypothesis, spelled G-A-I-A, after this lady, who is the Greek Earth Mother goddess, Gaia. We might then consider our days and nights to be like the heartbeat of Gaia, the seasons to be her breaths, the tropical rainforest resemble the lungs, and the oceans are like the circulatory system. So, if the whole planet does behave like a huge living system, what, we might then ask, are we doing here? What is humanity's function in this system? To get some perspective, let's go back and look at how we came to be here, at the whole evolutionary process which has led to us. According to current scientific theory, the universe started with a big bang. Pure energy, light. In the beginning, there was light, something science and religion actually agree upon. Then this energy quickly condensed into electrons and protons, the first elementary particles. And then these very simple particles began combining to form the first simple atoms, which themselves began collecting together to form more complex atoms, and more complex atoms, until the whole of chemistry had evolved. Next, these different atoms came together to form molecules, like this amino acid, one of the basic building blocks of life. These, over time, began stringing themselves together to form much more complex molecules, like DNA, containing millions of atoms. These molecules then grouped themselves to form the first simple living organisms, bacteria and algae. Over time, these too collected together to form multicellular organisms, simple sponges, and the first plants. This process of progressive complexification and organization continued, leading eventually to the first fish. Now, fish represent a very significant stage in evolution. For fish were the first creatures with a skull and a spinal cord, and inside was the delicate nervous system, which now, for the first time in history, was protected by a case of bone.